just to reiterate what I was saying before I started this. What you guys experienced was approximately like a fourth or a fifth of the total FRQ section. The second half, the FRQ half, you'll get 90 minutes to get through either 4 or 5 FRQ questions. Like I was saying, the size or difficulty of each question varies a lot. This was one question, but it was a huge question, right? The amount of points is kind of going to be your indicator for how big of a section or question this will be. 12-point question, that's a lot. That's a big question. Some of your other FRQs might only be like 5 points. Like write a paragraph in response to this question that they ask you, and you get like 5 points for that. That's a lot less than this one. So the time you spend on that question would be a lot shorter. You might only spend like 10 minutes on that 5-point question. Tentatively, I don't have this confirmed. I think the FRQ, I don't know if it's a set amount of points, but it's probably around 45 or 50 total points. So if you take, how much time do I spend per point? That's where I roughly got a 22, 23 minute estimate. Right? So this is a 12-point question. If you spent 2 minutes per point, right, you'd be up to 24 minutes. It's not actually, so you kind of shave a couple minutes off. So that's why I did like 22, 23. Right? That would be what you would want to spend the maximum time on this question so that you have enough time to get through all the other FRQs. Experimental design questions are tricky. They're usually the big ones. I can probably guarantee you'll see one on the FRQ. They almost always have experimental design bundled into the free response questions. What I want to do now, I don't really care how you guys divvy it up. If you want to do you want me to do it random, or you just want to do like a big swap with other people? It doesn't matter. You're going to help give someone else feedback. But I'm going to give you the grading rubric so that you can practice grading these with the rubric. You're going to practice, see what they're looking for, and then you're going to get yours back and see what you got. Yeah, do like a 3-way swap, 4-way swap. All right, if you're a virtual student, I'll give you the guide. So you'll basically grade your own. That's going to be the easiest. So set yourself up for that 23 minutes to do the FRQ. Practice actually doing it. Then when you're done, look at the guide and grade yourself. Practice grading, see what they're going to be expecting on an FRQ, and then also give yourself a grade. Like, what score would I have gotten if this was an actual AP FRQ question? All right, so did everybody switch around? Just swap with somebody?
Okay, this is cool.
I don't know. You didn't put an R. If you want to write it in,
Yeah, I'm just going to say you got all of them.
Yeah, I think you got all the chart right. Jeff definitely got it. In fact, we got 6. That's how
Okay.
We got like 200.
So if you one thing that I need to point out about this grading rubric, I don't know what it did. The formatting is all goofy. The first section, so question part A, it lists the answers. It lists point by point what the answer should be. Then it gives like the score range. This section should be a 0 to a 5 points. But then it relists the point distributions. And I don't know why it's duplicating it. So you need to, it was confusing me for the longest time why it was so long.
You got this off the College Board website, correct?
Yes.
That's why, because the website is garbage.
I don't understand the formatting it did. So just so you're aware, it will list what points are earned for question A. It'll give you the score bar, and then it will relist the points. So just ignore the other one. Then part B, it'll list the point answers, the score bar, and then it will relist the points. Just ignore that. And part C and part D are the same. Again, I apologize. I literally don't know what it did. I got it from the internet, like College Board printed it for you guys. And I don't know why it's formatted, because it's exactly the same above and below the score bar or whatever it is. So I want to go through this together. Oh, I'm going to need to. But I want you to start looking through this and start with part A. Alright, we're going to go through this kind of slow, looking at like how to grade these. Okay. So this is the question. I broke this up so you guys had space to work part by part. So notice, parts A, B, C, D. Those are the main parts. So you're graded. You get points for part A, points for B, C, and D. That's how it's broken up. You'll notice part A has 5 total points that you can earn. Right? So when you're grading these right now, I want you to actually do this for the other person. Right? You're going through these. Right? So point 1. Again, you're pretending like you're an AP grader right now. This is a student's test they submitted and you're grading this FRQ question. Huh? Point 1, right? If you're looking at your student's work for part A only, it says they get a point if they've indicated valid measured quantities.
If we don't know what the valid measured quantities are, that's not.
So in a real grading, they literally have a list.
Yeah, but for us grading it, like, you know.
But that's why we're talking about this, right? If they're asking you to measure the electrical conductivity of the plate, you're going to be like, what? That has nothing to do with the question that was asked, right? The question's talking about it's rotational inertia. There's rotation. There's torque. This is basically Unit 3, which is a little bit circular motion gravitation. That's part of the topic that this question is on. The other part is Unit 7, torque and rotational motion. If you don't have measured quantities related to those two, that's not a valid measured quantity. Right? This point is not earned if in their procedure they include measured quantities that aren't listed here. So that's another thing you're going to have to check. Did they list a quantity or something here, but then in their procedure down below they start talking about a bunch of other stuff? That you have not earned the point because you didn't actually list all the quantities that you put in your experimental procedure. Right? However, if you're looking at it and they're measuring things like maybe force applied tangentially, if they're measuring torque, if they're measuring angular speed, if they're measuring angular displacement, right? If they're measuring time, all of those are completely valid and on topic for the question. Okay? Second point, did they list equipment in a way to measure the quantities? Now, the ideal way to write this would be quantity if you made a table like this to address part 1, 2, and, well, just part 1 and 2, makes it really easy for your grader because you're telling them, I'm going to measure, let's say, time. This is the variable for time, and I'm going to use a stopwatch. That's part 1 and 2 done. You've identified all the measured quantities. You've added an extra, like, hey, every time you see this letter, that's what I'm talking about. And you've told them exactly what piece of equipment you're going to use to measure it. So that's a personal recommendation for any of these experimental design. They'll likely ask you, what are you going to measure? How are you going to measure it? Do a table like this, put it all in one neat, clear table. So then you're looking through, did they list equipment in a way to actually measure this stuff? If they did, then they also get a second point. Third point, practical procedure that uses these quantities. So you need to read through their procedure and critique, like, okay, does this make any sense? Does this actually use the quantities that they told me were going to be used in the lab? Right? Does the procedure, does it make any sense? Does it go in logical order? Is it related to the topic itself of determining frictional torque? Does it go step by step? Think back to the peanut butter sandwich video. Can you go step by step and actually see this stuff happening? Or does it have like 3 total steps and it's just assuming a bunch of stuff? Right, so that'd be another point. Plausible procedure to actually determine the torque. Does their procedure end up leading you towards, here is how you would find the frictional torque? That was the whole point of the question, the whole point of your procedure. Does their procedure lead you to that conclusion? And a point that I want you guys to make sure you don't miss, experimental uncertainty. Right? Did their procedure say measure it once and that's your answer? Or did they tell you do 5 trials and find the average? They will always, always look for some method to reduce uncertainty. So when you're doing an experimental design question, always add, the easiest way is just in your procedure, record multiple measurements and find the average. When you do multiple trials and you get the average, you're starting to weed out some of the errors that happen in one trial versus the other, and you get more accurate measures. There will almost always be at least 1 point for uncertainty. The easiest way to get that point is in your procedure, tell them, do multiple trials. Find the average. Find the standard deviation to measure uncertainty. Whatever it is, they want to know, are you thinking about uncertainty? So again, give them the points that they've earned based on the rubric. And what you could do is, like part A, you could give yourself a subtotal. Like, they got 3 out of 5 for that part. 1 out of 5 for that part. That way you can kind of keep track. That is part 1. Or part A, excuse me. Notice, the methods, they get, the grading rubric will be even more detailed for the actual test, but it gives you, here are some of the actual procedures that would work. Now, if they give you one not on there, but you go through it and it actually makes sense, and it works, you give them points. Okay, so then it repeats it again. I don't understand why. Part B. Part B is different. Now Part B has a total of 3 possible points. Part B was saying, okay, describe how the data that you just told me you're going to get in your method could be used to analyze or determine frictional torque. And it goes on to talk a little bit about you can't assume that the friction is independent of the speed. I think why they did that is you could have a shortcut answer of like, oh, it doesn't matter if speed, boom. But they want you to get measurements based on your data. Right? It's an experiment. You have to use your data. So part B, do they have an expression for the necessary angular quantity, whatever it is, that comes from their procedure? If they're asking you to do F equals ma, and nowhere in their procedure does it talk about force, mass, or acceleration, that wouldn't get a point. You don't get to do calculations if you haven't told in the procedure, you haven't gotten those numbers. So if they're doing calculations or equations that use the information that were used in the experiment, you're good to go. That's a point. Your second point is for actually finding the angular acceleration. If somewhere in their answer to part B, they've given you an equation that you could use the information and calculate angular acceleration, that earns a point. The third and final point is combining these two and having some equation that lets you calculate frictional torque. Now what that would look like, do you remember what torque is equal to? Yep, moment of inertia, capital I, times what? No. Acceleration. Remember, torque is the rotational force. So use Newton's second law. F equals ma, but now it's torque equals I alpha. If you find alpha from your data, you know, right, the question told you. You know the moment of inertia. You know I. Right? So if you measure acceleration and use the equation for what torque is, you can calculate torque, and that's the whole point of this lab. That's why you get a point for getting acceleration, point for getting torque, because that's the whole point of this, and then you get a point for using the variables that were in your procedure. Those 3 points get you points for part B. Is that making sense as you're going through these and kind of grading? Because I want you to give feedback to this person. Like part B, right, tell them you got 2 out of 3 points. I would help them out and label, oh, here's their equation for torque, and write a +1 by it. Let them know that that's where they got a point. That'll help them, and then you, when you get yours back, review. Questions on B? Okay, let's talk about C. Part C, there's a total of 2 points available. 1 point, correctly relating procedure in either A or B to assumption of dependence or independence of frictional torque. That point is essentially, when you answered yes or no, do you give reason from your part A or your part B to support your reasoning? Basically, this is, if you correctly use your procedure to support your choice, you get a point. The second point is if you basically gave the correct answer for connecting the analysis to the dependence of frictional torque on angular speed. If you actually said, yes, it does depend on angular speed, then you get that second point. Again, you connected the analysis to the dependence of frictional torque on angular speed.
It's kind of deceiving.
In what way?
Because it says either answer may be correct depending on your design. But then you only get that second point if you say yes. Or maybe it's just correctly relating the first part to
Oh.
the others.
I think you're right. Dependence on would be whichever one you argue, if you argue correctly.
Yeah.
Okay, that's
Because you can argue something but then choose like the wrong answer, so they kind of go against each other. Because you can like
And
try and defend
yeah.
something but say the wrong thing and then defending the other thing.
Yeah, and that's a great point because I forgot, if you read the question, your analysis depends on your experimental design. You could have done multiple different experiments to get the same answer. So, in that case, you can give very different arguments using your experiment for either way. So, good point. I guess that's my fault. I misinterpreted this statement. You get a point for using your procedure in your answer. The other point is for correct reasoning or correct argument of here's what I did, here's why it supports my answer. And that's a good point. The answer in this case actually doesn't matter. Did you use what you wrote in your experimental design? And did you use it in a logical and correct argument? If you did, then you got both points for that section. Because it depends on your experimental procedure. It could look very different. Good point, Maggie. So that one, you're going to have to read through their response. And did they use what they said previously in their problem? If they're pulling stuff from you don't know where, they don't get the points. They're not using their procedure, what they did in this, imaginary scenario. And then 2, did they have proper analysis or reasoning? Final point, or D, section D, again, there's 2 points available. D was, describe how the procedure could be changed to determine whether the frictional torque is constant as speed changes. So it's saying, how can you modify your original experimental design to find frictional torque? How could you modify it to find if that frictional torque depends on the speed? If no modification is needed, state that explicitly. Either way, describe how data could be analyzed to determine if that frictional torque depends on speed or not. One of your points comes from, so for a modification that has any additional trial, or for correctly and explicitly stating that no modification is necessary. So you could say no modification necessary. If that's explicit, point. If they said a modification is necessary at a different angular speed, if they've said that is the modification needed, they also get a point. Either one you choose works. The second point is saying how that setup or analysis could plausibly determine if the frictional torque depends on speed or not. Again, their answer. In this case, you get a point for an answer. If you say it doesn't matter and state it, you get a point. If you say the opposite, that it needs some more trials, and you need to do the trials at different speeds, point. In this situation, there isn't a wrong answer. The second part is, can you argue that? Can you indicate how you would actually answer the question from the unaltered experiment, if that's what you said, or the modified experiment, if that's what you said? If your argument makes sense, you get another point. So again, take some time to make sure you graded these. I would recommend give them a score for each letter. They should get 4 sub-scores so they know how they did on D. How did I do on C? And then at the very top, add them all up, and what did they get out of 12? And again, once you do that, hand it back to the person, but be open to dialogue. Like, if the person's like, wait a minute, why'd I lose this point? Talk to that person, right? We're not expert graders. We might have made a mistake, or maybe you could... Grading them is kind of difficult.
I just had no time. It's just, I'm going to let you, if you want to go back to the rubric to try and, I don't want to work everything. Just in case you wanted to.
So again, what you can also do is when you get yours back, you could go, again, double check their grading, right? Look at the rubric and see, do you agree with their grading? It should, and if you don't, just have a conversation with them. Like, don't be rude, like, you idiot, you gave me points off. No, talk to them, right? Have a dialogue of...
You did. It was valid.
Yeah, like, why did I get this point wrong? I think I did meet the criteria. Discuss that. That helps you learn kind of what's expected on these. You can also regrade your own. You could go through and try and grade your own work see if it matches. Using that rubric helps you get an idea of what they're expecting. You got a chance to practice an FRQ and then get a little bit of feedback. The rest of class, I want you to take time, look over these, learn something from these, talk with other people, talk about like what do you think the actual grade should have been. I'm going to pause the video. That's the only thing I really wanted to focus today. The other thing I'm going to do as you're working on all, I did this last semester, I'm going to check in with you guys of like, what AP class are you still in? It hopefully didn't change. What are spring extra credit or extracurriculars? I want to know, are you in a different sport for this semester? Are you still in band? Whatever. And then I'll ask you again, okay, what are your struggles? What are you worried about for coming up for the rest of the class or coming up for the AP test? But I'll just randomly come around the room and one-on-one. Virtual students, I will email you and ask you these questions and ask you to respond to those. That way I can, again, still know what's going on with your schedule, your extracurriculars, things like that. And that's all I got for today.